3:20 to do a proper presentation. So our next speaker is Rainer. Rainer comes from Austria. He's an entrepreneur. He runs a consultancy there. Their core competence is working with Azure, the Microsoft Cloud. So I was talking to him yesterday, and he mentioned that when Microsoft announced that they're going to create Azure, the first beta announced that they completely changed their business model and decided to go on. So he's been using Azure for 10 years now, which is absolutely amazing. And this is for all of you that are building things on the Microsoft platform then. Rainer has 2 MVPs and he's a regional director for the Microsoft MVP program. And I really hope that this is, most serverless days end up being all about a particular cloud platform. We want to kind of bring a bit more variety here. So thank you very much for coming. Thank you, Rainer.
Thank you very much. Thank you for this nice introduction. I'm really glad to be here, and I'm looking forward for the next 45 minutes. It will be a different talk than the talk I heard before. It was an awesome talk before, but now you will not hear me telling a lot of stories or showing slides. We're going to do demos, and therefore, please stop downloading YouTube videos or whatever you do, because if we don't have a functional Wi-Fi, I can't do my demos. Yeah, we'll see. Okay, let me quickly introduce myself or give you a little bit of background. I'm a passionate programmer. I love writing code. This is what I have been doing for the last 25 years. And although I'm a consultant, every day when I can sit down and write some code is a good day for me. Therefore, serverless is exactly the thing that I want to have, because I hate hardware. All the things where I can't write some text files, I don't like them. They break, and you have to order them, and then you have to wait until they come from the other end of the world, and it's a mess for me. I love software. And when I came across the idea of platform as a service, and even later on serverless, this definitely got me. This is what I wanted to have. You see, when I describe serverless, I always tell the story of my little niece. She's 4-year-old, and when she wants to watch the, let's say, latest Disney movie, she knows what to do with the TV set. Plug it into the socket in the wall. And she doesn't care that there is a lot of engineering going on behind the scenes to bring the electricity into the plug and power her TV set. She simply doesn't care. And I, as a developer, I love to be my little niece. I don't want to care about servers. I am aware of that there have to be servers. Some CPU has to run my code, but I simply don't want to care about it. And this is the reason why serverless is really important for me and why I really love this concept. And I would like to show you how serverless works in the Azure cloud in the next upcoming minutes. But let me first make a quick show of hands. Who would say she or he is quite familiar with the Azure platform? Okay. Who would say you have tried it, but you haven't really gotten into it? Okay, still the minority. Okay, let me quickly give you a very brief overview. Microsoft is one of the 3 very large cloud providers on this planet. They have dozens of data centers with millions of servers distributed across the globe. In some areas, they are market leader. In some areas, they are second or third. But their cloud investment is really, really serious. If you take a look at their balance sheets, you will see that Microsoft has completely rewritten their business plan in the last 10 years. Now they are no longer a licensing company, they are a cloud company. And what Microsoft did from the very early days, and maybe this is a kind of differential factor compared to other cloud vendors, they focused on platform as a service. The first services that they offered were not virtual machines. In fact, when I started with Azure, there was no virtual machine. There was just platform as a service. So Microsoft has a strong history in that area. Today, I will not going to talk a lot about Azure in general. We'll just focus on one piece, and that is Azure Functions. Because this is the most important serverless offering when it comes to running code. There are more serverless offerings when it comes to, for instance, storing data. You have a serverless SQL server. You have serverless NoSQL servers. There are serverless offers when it comes to storage, like blob storage, file storage, and so on. All these offerings are like the plug in the wall. You don't have to care about servers, but we are going to talk about Azure Functions, which is the thing that runs your code in Node.js, Python, JavaScript, Java, C#, whatever your favorite language. Good. Let's jump right into it. By the way, let me quickly show you that if you want to get in contact after this talk, or if you want to link yourself up with me via LinkedIn, Zing, or whatever, go to this easy to remember URL, and here down at the bottom you will find a lot of links to various social medias, and especially important is this one. I'm going to record this session, so if you want to rewatch it, if you want to recap what I do, or if you want to forward it to a colleague, for instance, just click here. You will come to my YouTube channel. I have a lot of videos up there, and this video will be up there, I would say, at the beginning of next week. Good. Now this is the Azure Portal. Maybe you have seen the Azure Portal before. If not, may I introduce you to the Azure Portal? That's it. In production, in real world Azure, you will rarely see this portal because in production we live DevOps. So everything is script, and this is what I like about Azure. You automate everything in Bash, in PowerShell, whatever you do. The portal is nice for demos like this. The portal is nice to take a look at something, but if you really want to do serious Azure, do whatever I show you today, but not in the portal, do it in a scripted way. That's a very important thing. I will not do it here because I only have 45 minutes, but please remember that. Forget interactive portals, just click here, this one, and you will get your favorite Bash or PowerShell, Cloud Shell here, directly here inside of this portal, and you can start hacking with Bash or PowerShell, whatever you prefer. As I told you in this demo, because of time, I will not go into scripting here. Let it give another 5 or 10 seconds, so that you see what I mean. Here it is. And now you see I can do whatever I want. I can write scripts. I can directly hack into it. I don't need any I don't know, local installation and things like that. It really works nice. So let's start with it. First thing I'm going to do is create a so-called function app. Function app is where everything starts when it comes to serverless on the Azure cloud. So what is a function app? A function app is a collection of so-called functions which share the same programming model, share the same programming language. They are deployed together, they are versioned together, they have the same settings, they are scaled together, so they logically belong together. You could call them a microservice if you want. So a function app consists of many functions, and yeah, it's the unit of deployment and management. Let's give it a name, Serverless Live. Let's see if this name is available. The first thing, what you will maybe recognize here, you will immediately get a URL with an SSL certificate. If you like it, fine. If you don't like it, create a custom DNS. That's absolutely no problem. Then we put it into a resource group. Because of time, I will not talk about resource groups here, because there are more interesting things to look at. And the thing that I would like to focus on for the next, let's say, 2 or 3 minutes are these two settings. First, in Azure, you can choose between running your functions in Windows environments or Linux environments. Essentially, if you write, like me, mostly C# and TypeScript and JavaScript code, in many situations, it simply doesn't matter. You can choose. However, there is a big difference, not a big difference, a subtle difference. If you want to have the full power of Azure Functions, you should go for Windows. This is not containers. This is a separate isolation sandboxing mechanism, which is called Kudu. It's an open source platform, and it has been around longer than the Linux support. And therefore, there are a few functions in the Windows implementation that are not available in the Linux function yet. So, if you want to have the full power, use Windows, but still, the Linux support is very, very good. The Linux support is completely based on Docker, and you will see me running a function in a Docker container in a second, okay? So this is the first decision that you have to make. I'm going to go for Windows in this talk, not because I'm so much into Windows. In fact, I love Linux more on the server, but I want to show you all the functionality that is available here in Azure Functions. The next thing is the hosting plan. And this is where it becomes really interesting. Let me do that one. The hosting plan, you have 2 or, to be more specific, 3 options, but the third one is a little bit special. The first option, the app service plan, this is the hotel model. What do I mean with hotel? You have to reserve a number of servers, a certain size of servers, and if you use it or not, you have to pay for it. If I would not have slept in my hotel room the last night, the bill has still to be paid. This is platform as a service. I don't care about the servers in terms of updating, patching, and so on, but I have to say how many servers and how large they should be. However, I can use nice auto-scaling and so on, but still I have to think about the number of servers. You know what the advantage is of this model? You are in control. If you know that you will now publish this awesome, cute video of a cat and everybody in this world will want to look at this video, it's a good thing, if you know that you are in control and you can choose how many servers and how large these servers are that will run your web application, for instance. But at the end of the day, you have to pay for unused resources. So we want to have a second option, and that's the consumption plan option. And this is where serverless comes in. If you choose consumption plan, you cannot choose any server number or size. You just say, Microsoft, I trust you. Here is my code. Please run it. Care for it. Yeah, this is now your Tamagotchi. Please feed it. Please keep it available. Please keep it healthy. Just care for it. It comes from the bottom of my heart, so please be nice to it. So this is what you essentially say. It has to do a lot with trust. But at the end of the day, you have to trust them. And if a sudden burst comes in, it will take maybe a few seconds or sometimes minutes. It depends on the triggers. We'll talk about triggers in a second, until it scales correctly. So you have the choice. If you are a developer, you don't have to make the choice between the hotel model and the electricity model up front. The code is the same. It's more an ops decision, not a dev decision. Okay, we are here at a serverless conference, so I'm obviously go for the consumption plan, and then I'm going to use a location, and since we are here in Europe, I will take West Europe, and I can choose between the runtime stack. Here you see the different runtimes that are currently supported by the Azure Functions. Can you do more? Yes, there is extensibility. So if you are fine with using some open source community maintained language bindings, or if you want to write your own language binding, you could also go for different languages. In my case, I will show you .NET Core. The storage, I have created up front storage and application insights. Unfortunately, I have very limited time, but let me say, application insights is awesome. It's simply awesome. You don't want to live without it if you are in the Azure cloud. What is it? It's essentially a monitoring platform. It gives you, it's a kind of X-ray machine built into your serverless stack. If you ask yourself, okay, what's going on in my serverless functions world, and which function did a call to a SQL database or a storage, and how long did it take, and which exceptions happen, and things like that, application insights will cover that all at a very low cost point and with nearly no programming effort. That's the important thing. So I love application insights, but I don't have the time to demo it. So give it a try, or take a look at my YouTube channel. I have videos up there. So let's create it. Now this function app will be created in a few seconds. Let me quickly navigate to the resource group that I have created for this talk. We can take a look at the function app being created somewhere here. Maybe give it a few more moments. I have created up front some already existing function apps. Here you see these 2 function apps. We'll use them during the demo. I will quickly take a look at that one. So I can already start walking you through, and once our new function app is there, we can switch to it. Now this is a function app. As you can see, it consists of 3 different things. It consists of functions. These are functions triggered by incoming messages, HTTP requests, or whatever happens in your infrastructure. Then you have so-called proxies, and proxies is a very nice thing because it's a built-in reverse proxy and, let's say, a lightweight API management. Do you want to rewrite some incoming HTTP requests so you get a nice URL scheme, for instance, and you map it in the background to different internal microservices and things like that? Proxies enable you to do exactly that. Super simple. You don't have to pay any extra. It runs inside your serverless infrastructure. And if all you need is a simple API management, which can be configured through a UI or through Bash, JSON files, this is exactly what you want. Again, I don't have the time to demo it, I just want to describe it. Slots. Slots is also very important. You can define multiple slots, for instance, a dev slot, a test slot, a pre-production slot, a production slot, and what you can then do is you can swap them. So you can have your production functions, and then you deploy with continuous integration, for instance, into a pre-production slot. You can do some smoke testing in the pre-production slot, and then a single button or a single line of bash script, and it will swap these two slots. And then pre-prod becomes prod, and prod becomes pre-prod. Then everything is fine. Sometimes bad things happen, production is no longer stable, and then you can press the button again, and this is your kind of safety net, because it will switch it around again, and everything's fine. If you now think, hey, what about my settings? Because in pre-prod I'm connected to a test database, and in prod I'm connected to the database. Don't worry, this is all taken care of, and not a single HTTP request gets lost. It's a zero downtime, one click put into production way. We love it, we use it all the time. It's a very important feature for us. Okay, let's see if our new function is already there. Let's refresh it. And here it is. This is my live function. Looks good. So let's create a function. Before I create the function, I would like to focus a little bit on this platform features here. You have to understand something. Azure Functions is standing on the shoulders of a giant, literally, because under Azure Functions, we have this powerful thing which is called Azure App Service. Azure App Service is one of the rock star services in the Azure cloud. It's a platform as a service and of course serverless infrastructure which is perfectly suited for running any kind of web apps, web APIs or WebSocket stuff. It comes with all the things that you as a web developer know and love. Things like, I don't know, I already mentioned API gateways, firewalls, load balancer, auto-scaling or serverless, a built-in editor, a nice troubleshooting portal, all the diagnose stuff, and many, many more stuff. Let's Encrypt integration, and all this stuff is built into App Service. And Azure Functions is just a layer on top of App Service. Those who raised their hands saying, yes, we are familiar with Azure already, the good news is all the knowledge that you have about App Service can be applied to Function too. So the way you configure App Services works in Azure Functions too. The whole kudu stuff, the environment for Windows works in Azure Functions too. The whole Docker support comes from App Services. It's nothing special. Okay? This is important, and therefore, if we want, we can dive directly into the function app settings, and this will bring us to the whole multitude of setting possibility and configuration possibilities that App Service gives us. Good. Enough theory. Let's create a function. The first thing, if we create a function, is something like this. I will say, for the sake of simplicity in the first step, I will say I will author my function in the portal, I will do a webhook, and I will hit create, and it will give me a function in a few moments. Here it is. This is a function. This is how a function looks like. Nobody does that in the real world. Okay? This is a very simple editor. You don't have IntelliSense, you don't see your mistakes, you don't have testing, so never do that in productions. Yeah? Never. In production, you will use Visual Studio or Visual Studio Code, and you have continuous integration, but for demo purposes, this is really nice. Now, what is this function all about? It's a little bit about code. Yes, of course. In this case, it's a C# script. Now, use your imagination. It could be your Java code, it could be a JavaScript code, it could be your compiled .NET Core application, whatever you want. PowerShell is also supported in preview. It is your code. This is what's going on here. But additionally, it has a bunch of settings. And that's the important thing. You have to understand that Azure Functions, it's not only about serverless. It's a program. It's a programming model, meaning that you can have so-called triggers. And the trigger doesn't absolutely need to be an HTTP trigger. Triggers are spread all across the Azure Stack. So if you say, hey, I want to run my function whenever somebody uploads an image into a blob, that could be a trigger. I want to run my function whenever somebody sends a message to my service bus. That's a trigger. I want to run my function when the webcam detects a face using artificial intelligence. That could be a trigger. The point is, the programming model frees you from having to know all the different APIs with which you can react on some kind of webhooks or things like that. It just does the integration automatically. So the idea of a function is that it makes it super easy to trigger your code. It can be HTTP, but it can be something completely different, including a scheduler, so you can run your function on a timely base too. Okay? So what we do here in the integrate part is we define the different bindings. In my case, I selected an HTTP trigger, but you will see a different trigger in a few minutes when I show you the more practical stuff in C#. We have input bindings. This is the thing that triggers your code, and you have output bindings. That's also very important. So your function can just return a value, let's say a JSON string, and then you can declaratively say, okay, take this JSON string and put it into service bus queue, a topic. Let's put it into Cosmos DB in a NoSQL database. So you put these functions together, you chain them together with the input bindings triggering your code and with the output bindings triggering something else. Because the thing that you output can be an input for the next function. Okay? This is what these triggers are all about. And the second thing is you define so-called bindings. The bindings are variables, essentially parameters to your function that are extracted from the input binding. So imagine the following. You want to run your code whenever a new image is uploaded in Blob Store. Okay? So what you want is you don't want to learn the blob API. You just want to have the name of the blob. That's all. And that's bindings. So it extracts interesting metadata, interesting data from the incoming, let's say, message or event and gives it to you presented on a silver plate. You just take it and you can just code with it. So that's the important thing. Please take this away. It's not just caring for your service. Azure Functions, it's a programming model. It's how you chain small functions to each other in a declarative way. As a developer, that frees you from learning a lot of different APIs. Good. And of course, we can do some management here, and we have some security stuff. For instance, an authorization level. I will set it to anonymous. Yes, it supports API keys. Yes, it supports Azure Active Directory. Yes, it supports other social providers like Google Auth and Facebook Auth and all this stuff. Please take a look at the documentation. I only have 45 minutes, so I cannot cover everything. In my case, I make it simple. I just say anonymous. Good. Now the trigger, oops, I didn't save it. Let's save it. Now the trigger is here. Oh, I didn't give it a good name, HTTP trigger. Nevertheless, I can immediately try it. I get the function URL. This is it. And we copy it here, remove the code because we put it to anonymous, and we say name equals Rainer, for instance. And if I run it, I will get back hello Rainer. So my function is on. And that's the beautiful thing here. This is not test, this is not development, this is not now we need to start a project thinking about our production environment. We're done. Of course, in reality, we all would write unit tests and integration tests and think about continuous integration and all this stuff. But at the end of the day, from a hosting perspective, we're done. That's production. That's production ready. It will scale automatically. We're finished. Good. So this works. Now, what's going on behind the scenes? Let me show you what's going on behind the scenes. That's pretty easy because we have our good friend App Services. And App Services has a Project Monaco built in. It is essentially Visual Studio Code running in the browser. You know Visual Studio Code? Probably many of you do. And what they did is they took Visual Studio Code, because it's written with HTML, JavaScript, and CSS, and put it directly into Azure Functions. So I have my good friend Visual Studio Code, and directly here in the browser, I can, for instance, edit my C# here. I can go into a terminal, for instance, and things like that, and mess around with the content of my file. Now I have to talk a little bit about deployment. You have three options when it comes to deploy your Azure Functions. On the one hand side, you can do what I did here. You take your files, maybe from Visual Studio or Eclipse or whatever, and you put it into a zip file. You send this zip file to Azure Functions, do a so-called zip deploy, and then Azure Functions will take your zip file, unzip it into the folder where Azure Functions run, and that's it. And it runs. That's a possibility, and then you can do things like that. But you have another possibility too, and I personally prefer this one. What you can do is you can take the zip file, put it into any kind of cloud-enabled storage like Blob Store, create a secure URL for it, and it will mount the zip file directly as a read-only folder into Azure Functions and run it from there. Read-only. It cannot manipulate the files. It will run directly from the so-called package. And that's really, really nice, because deploying a new version is then just uploading a zip file onto a Blob Store, for instance, and that's it. Deployment becomes really a piece of cake. But now I can show you a little bit what's going on behind the scenes, because if you take a close look here, you will see that we have a folder here which is called HTTP trigger 1, and we have our script, and then we have a bunch of configuration files. And the message that I want to give you here is Azure Functions is nothing more than a bunch of configuration files in your code. If App Service recognizes these files, it will say, oh, this looks like an Azure function. I think Rainer wants to use our Azure Function programming model, so let's start Azure Functions. So essentially what you have to do if you want to create a new Azure function, let's do that. Oops, I didn't want to do that. I wanted to do that. Let's create a directory. HTTP trigger 2, cd into HTTP trigger 2. Now copy the files. Now let's go back here, refresh it. And now we are here. As you see, we have a new function. It's nothing magic. The portal does nothing magic. All it does, it gives you a nice facade on top of a bunch of files, because that is what Azure Functions is all about. And I love that as a developer, because now I can have my microservice sitting in one folder where I have all my C# code or TypeScript code or Node code or Java code, and I can run it locally. I can check it in, I can check it out, I can just deploy it by deploying files. That's all I need to do. The portal is just for beginners, for demos, and for doing some troubleshooting. That's it. Okay? That's an important one. Now, which config files do I have? I have the function JSON here. Here it is. And all the settings that I told you about the trigger, HTTP trigger, and the bindings and the methods and so on, it's all in these config files. Nothing magic. Everything is JSON, easy readable, no binary files, super easy to handle, super easy to maintain, for instance, in the source code, in a source code management system. Okay? If you want to automate building, that's easy. Just run it through your favorite CI tool. At the end of the build process, create a zip file with all these files in it, mount it into the Azure Files folder, and you're done. Okay? That's essentially it. Good. Good, good. Next step. How do I do that in a more realistic scenario? Let me open CMD here, and let me open my script, because otherwise I will do something wrong. What I will now do is I will simulate a more practical example. I would like to write a new function locally on my machine with Node.js. In the last minutes, I will show you C# too. So let's create a new function app, and this time I don't use the portal, I use the function tooling. I install the function tooling. It's just a Node application, npm install -g something, and then you have the function tooling installed. It's cross-platform, it works everywhere. And now I have the same settings files. It's now a function app. This is my microservice. And once I have the function app, I can add my functions. In this case, I'm using JavaScript and Node.js to add a function which I happen to call say hello. It's the same that you have seen in the portal. And I can choose which trigger I want to have. Do I want to run it when Cosmos DB it does some inserts into a Node.js, NoSQL database, or an HTTP trigger, or whatever? I will go for the HTTP trigger because you've seen that before. Now, guess what? It's just folders and files. Here, I have a folder exactly what you have seen in the portal, but now I'm doing it locally. So let's open this up in Visual Studio Code, and you will see this is exactly the same code, but this time I have chosen to go for JavaScript. This is the same application, very, very simple demo, but now I'm locally. So, do you want to use TypeScript instead of JavaScript? Do you want to use your own testing tools and things like it? Now you have it locally. It's no longer this Hello World demo in the portal. This is real. This is a real development environment with everything you typically know and love. And how do I debug this stuff and run this stuff? Well, that's simple because you just can run it locally. But what I shouldn't forget is that I have to take this one to anonymous, because otherwise I cannot show it to you quickly. I say func start. If I say func start, it will run locally, and of course you can attach your debugger. It works with C#, it works in Visual Studio Code, it works in Visual Studio. This will start exactly the function runtime running locally on my machine. And now I have it here. See, it now listens on localhost. I don't need an Azure cloud for that. So currently you can download your favorite YouTube video because I don't care. Here you have it. And if I run it, let's run this guy. Is it the right one? Yes, it is the localhost 770. And API, did I run it at say hello? Yes, that's true. Good. And here it is, hello Rainer. Just to show you that it's that I'm not cheating, let's change the name, run it again, and it says hello Tom. So this is now running locally. I can do debugging, I can do whatever I want, and when I'm done, guess what I do? I put it in a zip file on a CI server, put it up in the cloud, and I'm done. Maybe use a little bit of swap magic to have a zero downtime deployment. That's it. That's essentially it. Do you want to run it on Linux in a Docker container? Absolutely no problem. We can do that because we got a Docker file. It built a Docker file for me. Here, see, this is the standard Docker file. Let's quickly build the Docker file. I have prepared the statements so that I don't mistype. It's running now a Docker, it's creating a Docker image that I can then use. I called it func say hello. Now we are leaving Windows, now we are entering the Linux world. You see the base of this image is not something magical, it's a ready-made base image from Microsoft for running node-based functions, for instance. So I can easily run that in this Docker container by just doing a usual Docker run statement, and I will do a port mapping for port 7071 because this is the port that is used by default. Now I'm running my function that you have seen that locally, but not on my Windows machine. I'm running it in Docker desktop in a Linux VM on my machine, and it should still work if I haven't screwed up. Let's see. You see, it is still the same, and let me show you, and here it is. It's still answering. This is now returned from a Docker container running my Azure function locally. And of course, if I go the Linux way for Azure Functions, I can now use exactly that Docker image. And I have another very important thing for you. If you don't trust Microsoft, and if you want to use the Azure Functions, or maybe you have to use the Azure Functions locally because you need to do some edge computing, this stuff is supported on your local Kubernetes cluster. There is auto-scaling, an auto-scaling controller for local Kubernetes cluster, of course also for Kubernetes cluster in the cloud. So if you are into Kubernetes and you don't want to use app service, feel free to do so. The function programming model is not bound to Azure. You can run it locally. It's open source. You can take a look how they implemented it, and you can run it completely off the Azure cloud in your own environment if you want. Okay? Good. Now, this was the Linux part. And for the last 5 to 10 minutes, I would like to switch gears a little bit, because that's all nice. That's all nice if you are into Node development, but I heard that a lot of you do .NET development. How does it look like and feel if you do serious .NET Core development? Well, I have come up, let me quickly kill this guy here. Where is it? Otherwise the port will be blocked. Docker rm and say hello, I call it say hello. Okay, what? Say hello. Hello. Good, done. Now let's switch to a Visual Studio solution. This is a larger application that I have on GitHub. If you are interested, let me know, I can show you the URL. And let's quickly take a look at that one. You know, I created this example for this demo because nowadays there must not be any demo where no AI is on the stage, and of course we need some AI. We'll do some license plate recognition. What I did is I created a microservice which is triggered automatically if a camera takes a picture of a car, and then we send it to an AI system in the cloud that will do license plate recognition, that will tell me the license plate, and then I will hand off this recognized license plate to some additional processing mechanisms. For instance, I will send it to a mechanism that checks the maximum speed and that checks a vignette, whether it is in the car, whether you're allowed to drive on this highway, and so on and so on. I will not go into the details. You can take a look at the code yourself. The important thing is, what I want to show you is this one. This one. Exactly, something like this. This is a function written in real .NET Core code. And in .NET Core code, you don't have to mess around with all these settings files. You just put attributes on top of your functions, and with that, you define the triggers. In that case, it's a blob trigger. Run my code whenever somebody uploads an image. And the return will be a service bus message. So when we have recognized the license plate, please put the result into a service bus queue so that another function can pick it up from there. So the function programming model in .NET Core is based on attributes and not on some strange JSON files, which maybe don't seem natural for a .NET Core developer. So let's try that. I have a breakpoint here, as you can see it. And hopefully this last demo will work. We'll see. Let's fire up the Azure Storage Explorer while the debugger is coming up. This is the debugger. It's just just pressed F5. Debugging experience is perfect. If you wonder whether you can use .NET Standard libraries to isolate your business logic and reuse your existing business logic and write XUnit tests, the answer to all these questions is yes, you can. Good. My tools are running locally. I'm not using Azure anymore. Everything is running here locally, and I've prepared this blob storage here. And let's quickly create a folder. I call it cameras. And inside of this cameras, I create a folder for the camera. It has the ID 0. And then here, I have some test images. Hey, we're here at the developer conference with a lot of nerds, therefore I had to pick a really cool car, so I picked one. And here you see the license plate. Good. Let's drag this car into the blob storage, and if the demo gods are smiling, my C# breakpoint should hit because of the blob storage trigger. Let's see, and here we are. Now my local machine recognized that in the cloud an image was added, and now I can do some processing. And let's see whether that works. I will do, this is the, here is the image recognition result. I'm using a system which is called OpenALPR, license plate recognition. It's a cloud service, and you see, with a confidence of 94% and a region confidence of I don't know what, the license plate was recognized. Very good, I really like that. Let's continue running it. And now we are putting the result of the read into a service bus queue, and the next function picks it up from there. So I'm splitting up the larger task of recognizing the license plate, processing the license plate, sending a message to an officer or the customer into many different functions, and I combine them using a message bus. That's a typical approach in Azure. And you see, it's easy to debug. I can let it run, and it runs, and it runs, and at the end of the day, it should at one point in time finish. We can check that, whether it works. I click on refresh and it's gone away. That's perfectly fine. I can do even more, and I cannot go into the details because I'm nearly out of time. I will now use a different image with a kind of blurred license plate. I prepared a blurred license plate. Let me run it. And the license plate recognition now has a confidence of only 94%. It is a little bit less than before. Let's simulate that the system now says, okay, this is not enough. So a human being has to take a look at the image and check whether this image was done correctly. So I will move it over here in the debugger and I will simulate a read quality of low. Let's go for it. What I did here, I don't want to have that one, I don't want to have that one. Okay. I will jump over a bunch of, this is the important one. This is a different kind of Azure function, because the Azure functions that we have seen by now are stateless and they are short running. They are fast. They finish within a bunch of milliseconds or seconds. But what if you have a function that runs for minutes, hours, or even days? What if you have functions that need human intervention, for instance? Then you can use so-called durable functions. And in this case, I'm using a so-called orchestration trigger. It's a special kind of Azure function that can run for seconds, minutes, hours, and days. It survives restarting the function app. It survives it survives shifting and rescaling and everything, because Microsoft cares for handling the state for you. And for you, for this demo, I created a workflow where I'm sending a message. Let me see, and if you see, you can recognize it here. I'm using the Slack API to interact with a human. So in this case, I did a so-called activity. You can take a look at the code. So the orchestration now talks to Slack. Slack will talk to the user, and when the user presses approve, Slack will send the message back to my microservice, to my Azure function, and I can continue working with. And if the user takes minutes or hours or days, I don't care, because durable functions will survive this time. Let's see. Let's see if it works. I have a bunch of breakpoints here, and if we are lucky, let's see. Here we are. This is it. You see? Please check the read for license plate BI. Whatever can you confirm, approve, and then we are done. This is what I wanted to show you. This is a human workflow written in a stateful Azure function in a serverless way. So let's click on approve. I cannot handle the response because in this demo scenario, I'm not in, I don't have a public internet connection that could receive the HTTP request from Slack. I have not set that up, but I think you get the point. So let's quickly summarize. What are Azure Functions all about? Of course, serverless. You don't have to care about servers. If you want to care about servers, you can. This is an opt-in thing. You can go the hotel way or the electricity way. Azure Functions is more than just serverless. It's a programming model. A programming model consisting of triggers and bindings. And with these triggers and bindings, you can take your functions and join them together. I showed you a demo about that. At the end of the day, Azure Functions are just config files and code. That's all. They work nicely in the cloud. You can debug them locally, and they run in Docker containers, even on your local Kubernetes cluster. And finally, you can decide whether you use stateless functions or whether you need state. If you need state for long-running functions, maybe with human intervention, then you should go for durable functions. The programming model is very nice. There is a detailed documentation out there how you write such stateful functions. They work very nicely in practice. This is what I wanted to demo, and I hope you have now a clearer picture what these Azure Functions are able to do. And maybe it feels for you like for me, being in the situation of my little niece, not having to care about how the electricity comes to the plug is exactly what I want as a developer, because with that, I can focus more on adding real value to my customer, on writing the business logic, and not caring about, how did you put it, blinking servers, because nobody pays me for watching blinking lights on my servers. I hope you enjoyed this presentation. I hope you liked it. I will be here for a little bit of time until I have to catch my flight. If you have any questions, come to me. I'm more than happy to answer them. Thank you very much.